Right, so we need the equation of the circle C. We are told what the centre is, and we're told a point that the circle goes through. Or in other words, we're told that the point A, 4 minus 5, is on the circumference of the circle. Because actually the equation of the circle tells you, really, it's the equation of the line that is the circumference of the circle, really. So, because we know that the centre is at the point 2 minus 1, we know that the equation, the left-hand side of the equation, is going to look like this. It's going to be x minus 2 all squared plus y minus minus 1 or plus 1 all squared equals r squared. So what we've really got to do is to find what the radius is. Now, because we know that it goes through the point A, 4 minus 5, if we just substitute the x and the y values in to our equation, we should be able to work out what r is. So 4 minus 2 is 2, and 2 squared is 4, plus minus 5 plus 1 is minus 4, and minus 4 squared is 16. And that's equal to 20, and that's got to be r squared. And really we've done it now, so we can write down the equation as just got to be x minus 2 squared plus y plus 1 squared has got to equal r squared, or in other words 20. And there we have it, the equation of our circle. Now the next part is asking us to find the equation of the tangent to the circle. Now remember that if we've got a circle, so not drawn very well, but here I'll do a circle. Now here's the centre of the circle, which in our case is the point 2 minus 1. Now we're told that the point A is at the point 4 minus 5, so let's say it's there. Right, that's A, and that's the point 4 minus 5. We want the equation of the tangent. Now the tangent, I'm going to try and draw this. It will be a straight line, and it will go something like, something like that. Okay, haven't drawn it great. But the important point to realise is that the tangent at the point A is perpendicular, and again my drawing's terrible, but should be perpendicular to the radius. So what we need to try and find is the gradient of the radius from 2 minus 1 to point A. So I'll call that the gradient from and the centre, I think, is, what do they call the centre? Centre is at the point 2 minus 1, okay. I'll call it, well, I'll call it O. So what we're trying to find is the gradient of this radius in red, which is the line OA. And that's going to be the change in y. So it's going to be minus 5 minus minus 1 divided by the change in x, which is just 4 minus 2. Minus 5 minus minus 1 is minus 4 over 2. So that is going to be minus 2. Now because the tangent, this line here is the tangent, because the tangent is perpendicular to the radius, which goes to the point A, we know that the gradient of the tangent has got to be minus 1 divided by the gradient of the line OA. Because remember, lines which are perpendicular to each other must be such that the gradients of those lines give a product of minus 1. So if you know one of the gradients of one of the lines, you can find the other one by doing minus 1 divided by that gradient. So that goes to a half. And we also know that it goes through, the tangent goes through the point 4 minus 5. So very easily we can find the equation of the straight line, which is the tangent, because it's going to be y minus the y coordinate at A, which is minus 5, equals the gradient times x minus the x value of the coordinate A. And what we can do then, if we times through by the left hand side by 2, we get 2y plus 10 equals, and then I expand out the bracket, which I don't really need to because it's just multiplied by 1. So x minus 4, and I get x minus 2y minus 14 equals 0. And there we have it. That's the equation of the tangent to the circle at the point A.